All right, guys, we are going to use the exponent properties we did yesterday, and we're going to apply them to some stuff today. So E is named after Euler, a Swiss mathematician number. It's an irrational number that was named after a Swiss mathematician, Leonhard Euler. The number is approximately 2.7182818, and then it continues on. This number is frequently used in banking to find the compound interest. I'm getting tongue-tied. I hope this doesn't continue. All right, to simplify, we're going to apply our basic laws of exponents with E as the base. So here, if you remember, you would do 2 times 3 and you'd get 6. When you multiply and the bases are the same, you're going to add. So 3 plus negative 2 is just E. Okay, we move over here. 4 times 7 is 28. Base E, negative 5 plus 8. These are like terms, so I can add them, and that would give me 3x. And then here, we divide, we get 6. And then we're going to subtract. And so that would give me 10 minus 5. So that would give me 5x. Okay, here we're going to distribute that 2. And that will give me 11 squared e to the negative 6x. 11 squared is 121. The negative exponent has to go to our denominator. Okay, so now if you'll take your calculator and if you were going to evaluate using E using the calculator, so you do that by hitting second LN. There's a little E above that. And then if you put E to the 12th in there, you would get 162,754.79. So this is just locating it on the calculator. When we put E to the negative 2/3 in there, we get 0.51. We're going to do round to the 2 decimal places. E to the 0.25 is approximately 1.28. Okay, so we will use E because of the ln. E is the base, the log base E of ln. Okay, logarithm, introduction, and relationship. So we know that logs are the opposite of exponents. We talked about that when we were graphing. So logs are the opposite of exponents, just as the opposite of addition is subtraction and multiplication is division. Log and exponents are inverses. So in math, we call those opposite inverses. So let's talk about the relationship. A logarithmic statement is pronounced log base B of y equals x. To convert logs to exponents and back, we're going to use what's called the drop and swap method. Don't you love all these math methods? So the drop and swap, okay? So if I have y equals b to the x, I'm going to drop my base and I'm going to swap my x and my y, okay? So for example, if I have 3 squared, and if that equals 9, we will drop the base. So that would be log of 3. And then I'm going to swap my x and my y. So that's going to be 9 equals 2. Okay. So here, if we have 5 to the 3rd equals 125, that will be the same thing as log, drop the base, swap x and y. So log base 5, 125 equals 3. Okay, so that's what we're going to do there. So let's move on and let's convert this exponential form, 6 to the 3rd, 216, to a logarithm. So we're going to have log. We're going to drop the base down. That's a subscript. And then we're going to switch the x's and the y. So the exponent becomes the base and the base there. Okay, so now here, the base is 4, so that's going to be our exponent. And then 4 to the 5th equals 1,024. Now this is going to make sense. If you put this in your calculator, 4 to the 5th is 1,024. So if you had written that any other way, it would not make sense and you would know you are wrong. Okay, so let's write this one. We're going to have log base 2, 32 equals 5. Okay, Here we have log, drop the 4, and then switch 1 over 16 equals negative 2. Okay, I'm going to show you something on this, and you might remember this rule. So if we take 2 and break it down with a base of 2, and then that's 2 to the 5th is 32. Then when you have these two, then that's just going to equal 5. So 5 equals 5. So that checks out there. Okay, rewrite this as exponential form. So that's going to be 8 to the 3rd equals 512. 8 cubed is 512. Okay, here 5 to the negative 3 equals 1 over 125. So if you remember negative exponents, that would be 1 over 5 cubed, and 5 cubed is 125. So hopefully this is making sense. Now what if you were asked to simplify log 2 to the 8th? That simply means what is it equal to? Set that up as an equation, convert it to an exponential function, solve for y, and rewrite it in log expression. So we would have log of 5, 125 equals y. Okay, so our unknown is y. So we can take the base, raise it to the exponent, and that's going to equal 125. Okay, again, 5 to the y equals 5 to the 3rd. So what does y have to equal for that to be equal? 3. When the bases are the same, you can just put the exponents equal to each other. So log to the base 5 of 125 is 3. So here we have log base 3 to the 1 equals y. So if I do 3 to the y equals 1, now I need to get the bases the same. So what could I replace this 1 with a base of 3? Well, we know from our exponential rules, 3 to the 0 will equal 1. So now y equals 0. So those exponent rules are important that you remember those. Okay, so here we're going to have log 4 negative 16 equals y. 4 to the y equals negative 16. Can I raise anything? So if I make this the base of the 4, 4 to what will give me a negative 16? Nothing. If I square it, it won't give me negative, okay? So this would be no solution. Undefined, no solution. Because no power, 4 raised to the power will not give you a negative 16. All right, so if we get log base 3, 1 to the 9 equals y, 3 to the y equals 1 over 9. Okay, so 3 to the y equals 1 over 3 squared, because 3 squared is 9. Remember, we're trying to get the bases the same. So 3 to the y, if I move this to the top, I get 3 to the negative 2. So y equals negative 2. Okay, so that's going to be an introduction to our lesson coming up. So hopefully you remembered part of this, and this is going to be something that you enjoy. Have a good day.